For this video we have a parallel circuit and there are three things to calculate. A, the current flowing at point A. B, the reading on the voltmeter, which is V2. And C, the number of electrons passing through point B in 2 minutes. The first thing is to look at the three resistors in parallel and find the equivalent single resistance for these three in parallel. To do this, we use the reciprocal rule. I'm going to denote R1 as the equivalent resistance. So 1 over R1 equals 1 over 3 plus 1 over 2 plus 1 over 4. And this gives 13 over 12. Therefore, the equivalent single resistance of the three resistors in parallel is the reciprocal of 13 over 12. So R1 equals 12 over 13 ohms. And similarly, for the two resistors in parallel, we need to find the equivalent single resistance. Now, because there are only two resistors in parallel, we can use the product over sum equation. So R2, the equivalent resistance, would be equal to the product, 1 times 2, over the sum of the resistors, 1 plus 2. And that gives 2/3 ohms. So this parallel circuit can now be rewritten in terms of a series circuit by having two single resistors, as I'm showing here. So this resistance will be 12 over 13 ohms, and this resistor 2/3 ohms. And we've got the cell voltage still as 6 volts. So using this equivalent series circuit, it is now possible to find the current flowing at point A. Here. So the first thing to do is find the total resistance of this equivalent circuit. So I'm going to denote that as RT. So because we've got two resistors in series now, we add the resistances together. So 12 over 13 ohms plus 2/3 ohms, and that gives a total resistance of 62 over 39 ohms. Now, to find the current flowing at any point in this series circuit, you have to apply Ohm's law, which is V equals IR. And because we want the current flowing through point A, we need to make I the subject, so I equals V over R. Therefore, the current flowing at point A will equal the cell voltage 6 over the total resistance of the circuit, which is 62 over 39 ohms, which gives a current of 117 over 31 amps. So that's the answer to part A. Now part B. Calculate the reading on the voltmeter. So we need to work out the voltage on V2. So using Ohm's law, we can say that V2 equals IA, because the current at any point in this equivalent series circuit will be the same. I'm going to multiply that by R2. So the voltage reading on that voltmeter will be 117 over 31. That's the current flowing. And this resistor here, 2/3, giving a reading of 78 over 31 volts. So that's the answer to part B. Now for part C, first of all we need to find the voltage across these three resistors in parallel. So basically here. So if you call that V1, we need to find V1. So again, applying Ohm's law, we have V1 equals IA R1. So that's going to equal so that voltage is 108 over 31 volts. You could check to see whether V1 and V2 are correct by adding these two together, and they should give you the cell voltage, which is 6 volts. Now, we need to now work out the current flowing at point B. So I'm going to denote that by IB, and that's going to equal V1 over the resistance on this branch here, which is 3 ohms. So that's going to give us a current of 36 over 31 amps. Now we need to find the charge that flows through or past point B in 2 minutes. So we've got Q, this is the equation, Q equals IT, and T must be in seconds. So the charge passing point B in 2 minutes will be given by the current flowing through that 3 ohm resistor, which I've just worked out to be 36 over 31 amps, times 2 minutes in seconds. That's going to be 2 times 60. So the total charge passing point B in 2 minutes is this amount of charge and charge is measured in coulombs, capital C. Now the charge on an electron over here, so charge on electron is 1.6 times 10 to the power of minus 19 coulombs. So now it's possible to work out the number of electrons passing point B in 2 minutes by use of the number of electrons equal the amount of charge passing point B in 2 minutes, which is that many coulombs, divided by the charge on one electron, And this gives 6.71 times 10 to the power of 20. And that's the answer to part C.